Chemicals is more or less forgotten in politics, even though that we know very much about it. I'm still very much concerned that we do not have enough engagement in this area from the political arena, not the least, even though that there is some. So, and it is difficult to compare, to focus on one area which is very much a matter of climate change today, but we have biodiversity, we have the issue of chemicals. Actually, chemicals is taking a lot of toll. Actually, a number of deaths, the most rude and dramatic effect of chemicals, which is, I would say, thank you, unfortunate that this is the way that we are still measuring, but it's a way to do it to really show that the number of deaths is approximately 9 million premature deaths, and this was measured up to 2016. There is a development of this Lancet Commission publication and work that has come out very recently, but very, very small adjustments on the numbers. They've become distributed between the different areas a little bit. So it's a lot of concern from pollution, and of course air pollution is one of the very important matters. Also lead. Lead poisoning is a dramatic one. So this is one thing. I was coordinating another work by WHO and UNEP, where we actually looked at endocrine disrupting chemicals. And one of the conclusions we draw that the disease risks due to EDC may be significantly underestimated. And I mean, this was, we were 25 experts sitting with this, and this is the conclusion from these experts. So it's for real. I'm also just showing, this is of course a slide that you are well aware of, but it's, I mean, before we come to the risk management, we need to identify what we do have. What are the exposures? Do they exist? Do the chemicals exist at all in the environment that we are thinking of? Among all chemicals that are presented, which of those are in commerce and so on? I'm coming back to that. So that's exposure and the hazard side, the occurrence and also the effects of chemicals before you get into risk assessment, because risk assessment area is so under developed in many ways. So very few chemicals are actually being risk assessed so far. But I want to actually concentrate initially on chemicals, because it's not rare to hear that chemicals is everything. So what are you talking about? It's this is the reason for life is actually what is it's a prerequisite, and I just, of course it is, of course. I mean it is. These are some fossils I found in the Czech Republic on a rock. That's the way. That's, of course, we all know that. But what in addition to that, we do have the anthropogenic chemicals that are just as anything else, compositions of the elements. Of course, for the organic chemicals, it's carbon, oxygen, hydrogen, and some other elements primarily. But this is for real, and that's chemicals by definition. But also we have the biopolymers, and which is in many cases a prerequisite for interaction with the anthropogenic chemicals. This is actually work that was done in the 1990s, where I'm co-author on, where we found this is a transport protein for T4 thyroxine, which also can bind, that you see in these pockets, metabolites of PCBs and cause some endocrine-related effects. So, what is chemicals in the common vocabulary today? I think what I see in the development over the years, which makes me quite confident in actually saying what I'm saying now, that of course it's just as defined in chemistry. But we can say that the general perception when we talk about chemicals, it's chemicals of anthropogenic origin. That's what the most common link to the language that is used by many of us working on environment and health issues. That's chemicals. Then it's the anthropogenic of that origin. It's a simplification, but I think we can live with that. What I want to say is that we can never change the natural occurring chemicals, not in an easy way, but the society has a possibility through management acting on the anthropogenic chemicals. We can actually handle, or should be able to handle that in some way. But when it comes to the natural occurring chemicals, it's a matter of decisions that you can do as an individual to avoid certain type of foods and so on. And of course, I have to confess that I failed in getting the most recent number of chemicals that have been synthesized so far and are present in chemical abstract system, number system. And I can just say that it's more than 160 million. I couldn't go back to the old link. It was hidden somewhere else, but it's a lot. And these are, of course, chemicals in the chemical context. It's organic and inorganic substances, and both naturally endogenous chemicals and anthropogenic ones. When it comes into commerce, we are talking about 140, 180. On the other hand, if we go back, and this is a number from just 2 days ago, when it's registered by ECHA is 22,668 chemicals. That's the ones that are registered. On the other side, the number that has been announced to be in use is a little over 140,000, but they are never become registered by ECHA so far. So these are numbers that you may refer to in some way. Among these, I think that maybe we are looking at 500 or so. But then we are not talking about the abiotically transformed, the products that are formed in air, water, in surfaces, in soil and sediments. And then the metabolites in addition to that. So what I normally do, I do not have that on this slide, is that I'm talking about a chemosphere of anthropogenic related chemicals of 500,000. I may be wrong, but not too far away. So, oops. Now I go into the core of what I'm going to talk about, because when I first saw the Sustainable Development Goals, the SDGs, I realized that nowhere I could find chemicals. Chemicals could not be found as a concept as in a non-toxic environment that we are talking about in the Swedish environmental goals. On the other hand, spending some time on this, I don't mind, I have to say, because they are, as you will see, everywhere. They are hidden away in the goals of for example, clean water and sanitation. And now I'm going to actually talk about those chemicals that we should actually be able to know. That's what we talked about, Maria, just before starting. This is actually what do we add in order to have water that is clean enough for drinking? Added for disinfection and so on and so forth. We have a preparation of water in order to come out the tap. So we should know that. Simple. If you are coming to affordable and clean energy, of course, it becomes a little more complicated because we are starting to burn it. We have a number of complicated structures that are coming out of it, but at the same time, it should be known. And of course, this is really the generator of carbon dioxide that once was far away and is linking to one of the goals that I'm going to show on this side in a little bit. Then, of course, it's becoming much more complicated when we are looking into this one on the SDGs, on industry, innovation, and infrastructure. We have a development, this is in euros today. 2016, 3.4 trillion euros is the production of chemicals, which is supposed to almost redouble in not that many years. This is around 2030, 10 years from now, a decade from now, it should be up. Of course, it doesn't mean that the weight is exactly redoubling. The number of chemicals that are being produced should be known, and of course they are known. So why don't we know all what actually is going to construction, to build the cities, to build do the manufacturing, the schools, the offices, the homes that goes in? It should be known, but it is chemicals, a lot of this. We do get to know some of that through actions in the by scientists and others. The last one here is on responsible production. Well, now I'm going to say it the way I like to say it. It's responsible production and consumption. It's actually the reverse in the SDGs. It's responsible consumption and production. But you see, responsible production is first step. And actually we did a work, it actually made us to clean the lab for half a year because we found contamination in the lab, we thought, that we couldn't deal with in the chemical analysis we were doing. It turned out that it actually was chlorinated paraffins in these hand blenders, and this made quite some big headlines around the globe when that was presented. And this is one of the cases where we never published that at that time. I wrote a letter to the Swedish Food Agency and to the Chemical Agency, and also the companies for all the producers of these hand blenders. I'm not going to tell the full story. You can ask me later on. So, but it shouldn't be there because you know how a hand blender looks like. You have the piston like that, and then you have the propeller or cutting piece here, and then it's sort of a shield. Actually, the liquid that you were blending was going up into this part of the blender, and brought down what was actually in here, which was in a feral chlorinated paraffins. So by, as Christina used to say, serendipity. All by it happened that we found it, because it shouldn't be in the cod from the oceans. So, I mean, all this we should know. Unfortunately, we do not. And of course, it is this very complex world with going into just looking at the pharma side, approximately 3,000 different active pharmaceutical ingredients, pesticides, some maybe between 1,000, 2,000 something, and then materials and goods and material. That's part what I just mentioned now, where we have a humongous number of chemicals. Cosmetics and personal care products, I think this is sort of interesting. How many, because they are registered, this is something that you can actually look up. So can you give me a number on how many chemicals that are registered in EU for cosmetics and personal care products? Anyone that is ready to lift the number? Above 1,000, I can say. Yeah, if you say wrong, I will always remember you, you know. So that it's dangerous to be wrong now. It's the same thing every time. Okay, do you want me to tell you? Yes. Yeah, approximately 30,000. I was quite surprised when I saw it. COSING is the website where you can go for that. But it's registered, it's there, it's in place. With some chemical knowledge, as ecotoxicologists, toxicologists, you can go in and do studies on chemicals that are active ingredients or ingredients in cosmetics at least. But that doesn't last for many of the others. I mean, of course, it's for the active substances in pharma and pesticides. And then we have the others, plus the transformation products that is really difficult to get into. And I shared this slide with some colleagues. You may have seen it from others, but it's coming from me. Because when it comes to bisphenols, bisphenol A, simple, wonderful. It's one chemical, isn't it? Yes. It's just like the PFAS, the fluorinated chemicals. It's PFAS, that's one compound. Which is it? But for this one, some time ago, it was only these 16, but this is not the complete list, because we have a number of fluorinated, chlorinated, and other derivatives that looks very much the same. This is a condensation product between phenol and acetone. We can have other aldehydes and ketones reacting with. So you have a whole bunch of these. A sulfone group which makes it, I mean, in one way, it's natural when producing or coming up with an idea. You try to see which are the other chemicals that can be used for the same purpose. And that's exactly what's happening now when substituting bisphenol A. You go to bisphenol F, bisphenol E, C, and S. The names are not just out in the woods. You can actually trace them by the name where they come from as a chemist. Well, the blender of chemicals looks very much like the globe. That's where it's happened. And this is where we are working, where I've been working more or less my whole life, is the Anthropocene global chemosphere. The chemosphere, that's where we have all these chemicals that show up. Since we have not been able to learn what is going in, we have had to look, and we have seen the effects in the environment. no poverty, zero poverty, which is the public health authority in Sweden that is using this for mother's milk as a tracer. But of course, the big one is good health and well-being, effects on health. And this is where I'm going to concentrate a little bit and look into some of the endocrine-related issues that I've been touching on. And of course, the chemosphere is very much a matter of clean water and sanitation. What do we see? The sewage sludge, the biosolids, what does that contain? Maybe we know a little more, Gunnar, than we did a long time ago. But this is something that where we have actually the answer to what we are distributing is the water that is coming out, this sewage sludge water, and the on the biosolids, and then the SDG number 13, climate action, or if you translate it into climate change. This is, in my perspective, climate change is nothing but an effect on the use of chemicals. Because as I said, it starts off with the energy production. That's where carbon dioxide is formed, and one of the components that is driving the changes in climate, just as good health and well-being is another effect of what is being done on the other side of the blender of chemicals. Also, what we have seen a lot of is what's observed in water and in both in water and on land. So this is one of the slides actually dealing with exposures, and we have exposures of chemicals everywhere. So it's well known to you, of course. Going a little more into good health and well-being. This is a slide from Carl Gustav Bornehag where we, well, at least part of it, to see the development of humans and their exposures and the effects, health, from the newborn till becoming old. Of course, this is a matter of a number of factors. The choice of individuals, smoking or not, eating, how people are eating. But in both these cases, there is an enormous number of anthropogenic chemicals. I've seen the number of chemicals from tobacco smoke. It's just incredible how much and how different they are among the not only polycyclic aromatic hydrocarbons, but others as well. And then this is not intentionally here for you to read, but actually we have been able, or through the work that Carl Gustav Bornehag has initiated in the Selma cohort, been able to follow what the mothers and their children are subjected to. And just for the reason that I happened I got a telephone call on the 16th of May this year, and that was from the Social Democrat Party, if they had some high-ranked politician. They said one high-ranked politician that wanted to draw blood for analysis. They didn't tell me who it was, and I happened to be in Montreal when they called on the 16th. On the 17th in the morning, I was at Sveavägen, and that's for sampling the blood of two individuals, the Jytte Guteland, the MEP from Social Democrats, and Margot Wallström. Actually, I guess this is the result of this made her to resign from being Foreign Minister of Affairs or something else. I don't know for sure. Anyway, it was a great opportunity to look at some of the chemicals. Margot Wallström, very interesting because she had done it in the early 2000s when she was commissioner for the environment in Brussels, look at that. But I just want to come back to what was a surprise to us, because this was the first time, it's the first blood samples we analyzed. We analyzed 4, there's 2 more individuals to add to this, but it's not included here, where we could go for chlorinated paraffins. And the total chlorinated paraffins, you see the DDE concentration here, you see the total PCB, Margot, the blue one, and Jytte, the other one. And I've been scared. I'm working in China, as you saw. Chlorinated paraffins are enormously high. It's up in the concentrations where we found DDE and PCB when it was really up on top. So I didn't really believe the results when I got them in July. So I had to go back and check on it. But sky high. So with that, and plus then having the fluorinated chemical, the PFAS, Margot has a higher concentration than Jytte. 20 years something, no, it's more than that, almost 25 years difference between the two, it is, in age. But of course, what we saw in these is that the PFAS chemicals and the chlorinated paraffins are now up on top, and the old traditional one has disappeared into much lower concentrations. I skipped that one. And showing that, of course, regulation matters. I mean, this is really very important to say that. The milk for PCBs, for example, has declined with maybe 10% per year since the legislation kicked in to ban PCBs. The same with DDE. But the others has not been there. And linking this then to what was a surprise for people that are not medical doctors is that the number of hormone systems that we have actually 50 hormone systems in humans, in mammals, but it's very much similar. It's very conservative. It's well preserved between species. You may even look at a crab and see similarities to humans. So it's a large number of hormone system. Is approximately 100 signal substances. Are you surprised that we do find chemicals that may fit into some of the receptors or interactions with the endogenous systems? No, not really. But what is surprising is that we have more or less entirely concentrated on estrogen, androgens, thyroid hormones, and to some extent also on glucocorticoids. That system is also studied to some extent. But there is a lot more to do. And of course, this has a relevance. This is from our work for UNEP, WHO, where we show this picture that the exposures during pregnancy and the developing fetus may have implication much later in life. Prostate cancer, Alzheimer, Parkinson's disease. Interesting with Parkinson's disease is that there is actually an outcome from my English is lacking here, from workers at that use biphenyl in the production, and you probably remember that, Christina. Nope. Actually, where Parkinson's disease was linked to one of these chemicals, biphenyl, that when I was young, you know, the paper wrapped around oranges had a really good smell. And when I started to work at the lab at Stockholm University, we had a jar with biphenyl. It smelled exactly like oranges. The thing was that the paper was impregnated with biphenyl, that we had in this jar in the lab for chemical synthesis. But so the smell of oranges when I grew up was biphenyl, not oranges. But a number of these effects can be seen much later in life. What we did was just looking at the number of endpoints that, I mean, not are specific, because if we are looking at female reproduction, for example, or male reproduction, it's a number of endpoints that can be hit in order to give the effect, the outcome of this. But these are all the what we looked into. Sex ratios in humans, thyroid-related diseases and disorders, looked at neurodevelopment in children and wildlife, and hormone-related cancer and so on. We tipped a little more into human health in this report, but we do have also the sustainability of wildlife population, and that was addressed to some extent. And this is what I'm going to show on the next slide here, which is, I think, extremely important for everyone to actually grasp and bring with you. Sitting in the facilities of ecotoxicology here in Gothenburg, I think it's of particular interest. Of course, if we are looking at the strength of evidence, how can we be sure that something is well, that is quite difficult to be sure, but we can with high confidence say that we are sure if we can explain an endocrine mode of action, a mechanism for the effect. If we can do that experimentally, if that is shown, we understand a number of steps, then we can be very sure. It's very unusual. I would say that even among the active pharmaceutical ingredients that we have today, we know in many cases, in most of the cases, we do not know this. Then identification of chemicals with endocrine disrupting properties linked to diseases outcomes in laboratory studies. If we can see it in laboratory studies without actually knowing exactly the mechanism, but can we repeat, can we see it, that is important, building the evidence. So I'm really going from the strongest evidence and downwards. Observation. This has been extremely important over the years to actually see this in wildlife population, a huge driver, and this is also for the future, I think, extremely important to use the environment, to use wildlife, what we see out in the environment, because wildlife is much more polite than humans and easy to work with, because wildlife doesn't smoke, don't drink alcohol, so they are more reliable in that way. And then, of course, what I'm going to show you now is a series of graphs where we see changes in the rate of incidences and disorders. So with that, I'm going to go through this very rapidly because it's associations. And of course, it's important to say that these are not evidence, but it's showing that something is going on and why are these increases going this way. For endocrine disruptors and hormone-related cancer, these are primarily EU countries. We have metabolic disorders, and I thought nope. The same thing over time from the 1980s and onwards. Increasing, and this is obesity development in these few countries. The cumulative incidence of autistic disorders in even fewer countries. This is not even a country, it's California, it's Denmark, and Japan that were studied. But this is also all reasons in the world to look much more closely on that. Fertility rates, highly discussed issue. but decreasing trends basically in all the countries that we had data for. So switching then from health and well-being to climate action. Of course, this is the generator of carbon dioxide through fossil fuels. But not only, we have the greenhouse gases, we have ozone effects on what has been added and used as, I mean, the short chain, very short and volatile fluorinated chemicals that were used was ozone depleting chemicals. Distribution of POPs, persistent organic pollutants, changes to the permafrost, releasing methane, and so on. So there are a large number of issues related to chemicals when it comes to climate change that is really the driver. However, the thing is that when it comes to communication, and this is one of the things I'm struggling with, is that it's so difficult to get through with the chemical issue. Maybe it's just because it's too complex. The climate side has become understandable to the public in stakeholders, politicians, and so on and so forth. And that is not really the case. It's complicated. I met politicians, they worrying about talking about it because they may say things that they cannot really explain or they don't understand themselves. So this is a communication problem. If we come to life on land and water, we have these dramatic and disgusting pictures of skulls that were eroded, linked. We have them in the Baltic among seals. When you get to northern UK, you do not see the same effect on the skulls. So this is an effect related to the chemical pollution. Effects on egg-shell thinning, but also that the effect, just as I showed you before, are decreasing as the concentration of, in this case, DDE was decreased because of legislation. But it's not enough there, because actually the consequences of this is going into almost all the other Sustainable Development Goals. It has to do with poverty, and it has to do with equality, and so on and so forth. These are linked to the effects of the chemicals. So actually, there are just two more goals that are not included here that I'm coming to, because what I want to show is how important the chemical pollution and the use of chemicals, and why we really should know all from the start what's going in. And it's actually these two that I do have on another slide, a little bigger, is quality education. I'm very much concerned about the competence provision and how this is developing, not only in Sweden, in the Nordic country, in Europe, and outside. There is so much more to know, and this is where the T is needed. And those of you that are engineers, you probably heard about the T, but I thought this was something I discovered. And that I did, but I learned I didn't. On the other hand, also partnership. We cannot do that by ourselves. Not even Gothenburg University is able to do all of this, even though you may be closest. I don't know. This is why I'm working with SVAX, that we work together in Sweden on trying to build partnerships to approach the stressors of chemicals in the environment. But that's not enough with Sweden. We have to go outside much more. What I'm talking about is that when I introduced myself, I said I'm an organic chemist by training. This is where I have some sort of a deep knowledge. Others of you have, it's in biology, in disciplines of biology, medical doctors, and so on and so forth. And when you go up this part of the T, you become able to actually work in collaboration with other disciplines, and even more, and finally also be actually able to communicate over the borders, which is extremely important. Just meeting with Daniel is really very, very helpful for me to broaden it into economy issues that I haven't really been into. I have contacts with environmental law and so on and so forth. But all the pieces of science and what we have in the societal sector is needed in order to actually handle these matters. And my last slide, next to last, is that I just said that to break the silo walls. And we just have to go to or stay in our academic world. I mean, where are we? The walls between disciplines and between universities is far too big, and big, huge changes. But it's the same thing all the way from the governmental bodies, the authorities, to many other places. So there need to be a big, huge change in this context in order to move forward. We've seen the legislation and regulation playing an enormous role. On the other hand, we are far away from being complete there. You have different bodies of EU, national legislation, and national bodies that are unable to actually regulate more than their own piece. Just talking about water, for example, I don't remember how many authorities are into regulations of water, but it's, if I say 5, it may be 4 or 6, but something there is. So it's going from the start for drinking water only. Do you get your water from Göta Älv? Yeah, I think so. But from Göta Älv to the tap, that's a number of different authorities are involved in this. But this is what I've been talking about is basically to look in the rear mirror, to look behind me, and what did we actually manage to do, instead of coming more and more rapidly into a situation where we can become proactive. This should not, what we have experienced should not happen. We have to have methods in order to be proactive in the future, to the innovation step, to get engineers in understanding fully the importance of their decisions and development in these cases. So that's what I hope for the future. Indeed. And my last slide is actually from Shanghai. It's a Swiss orchestra. It was 85 or 86 musicians there playing. And I think it's my last word for this presentation is that if they can play so nicely the music, why can't we do it in our science? We need to play together in order to achieve what we really need to do in order to get to the point where there is a sustainability for next generations. Thank you so much.